Welcome back to another AP Pre-Calc video. I'm Mr. Hibble. Today we're continuing our 3.13 notes. This is the second section of it, looking now at double angle formulas. I'm not necessarily going to go through a proof of finding why these statements are true. I'm just going to use them and accept them for what they are right now. I might come back if people want and do a video on the proof later on. Okay, but let's just go ahead and just write down what these double angle formulas are. Realize the left-hand side is from the last video, our reciprocal identities, our quotient identities, and we did prove and verify the Pythagorean identities as well. But again, not going to go through a proof of these ones right now. Let's just write them down. So what we know is sine of 2u, or whatever the angle is the same as 2 sine u times cosine u. Okay, so sine has just one singular statement that we can change it to if its angle in the middle is being doubled. Same idea with cosine, but this one has multiple forms you can use. They should all work in different ways, but they're all just true statements that you can utilize. Here is one of them, cosine squared u minus sine squared u. Another one that works is 2 cosine u minus 1. Notice these forms are nice because we get rid of the 2 on the inside, which would make it more complicated to evaluate some different problems. And we're leaving it just with the u instead. Another form, a third form for cosine is 1 minus 2 sine squared u as well. Okay, so all of those three are for cosine. Last one is for tangent. So tangent of 2u is equal to 2 tan of u over 1 minus tangent squared u. Okay. So using those 5 different formulas there, let's go ahead and look at some of these problems. Example 1 says find sine 2u and cosine 2u given sine u and u in the second quadrant. Okay, let's think about that. Let's draw a little diagram. Here's my x and y axis. Sine, think back to geometry. Sine is the opposite over the hypotenuse. So, okay, I know I have some right triangle over here where the opposite of my u value is 2. The hypotenuse is 5. Realize I need to know this x value if we're going to proceed. Well, the x value. Realize we can find that by using our Pythagorean theorem. 2 squared plus something squared equals 5 squared. So solving that briefly, we end up getting b equals the square root of 21. Okay? But be careful in this case, because if I put square root of 21 here, yes, that's the value we just found, but it's not the right one. It doesn't actually work. And there's a small thing we need to do. We're on a coordinate plane right now. We're in the second quadrant. I know in the second quadrant, the x value is always negative. We go left root 21. We go up 2 to get to that coordinate. So from here, then, realize we have a triangle. We have a right triangle. I could find sine, cosine, tangent, whatever I need. For example, sine of u is just 2 over 5, like they said. Cosine u, then, would be equal to adjacent over hypotenuse, which is negative root 21 over 5. Okay, so just some small things that we could find. You could find tangent as well if you want. Okay, but what we were asked to find is sine 2u and cosine 2u. Well, sine 2u is the same thing as 2 sine u times, fix that real quick, times cosine u. Okay, well, replacing different parts then, I know that sine u is just 2 over 5. I know cosine of u, that's a terrible u right there. I know cosine of u is negative root 21 over 5, and I just need to multiply those two statements together. This 2 times that top 2 is 4. 4 times negative root 21 is negative 4 root 21. All over the denominators of 5 times 5, which is 25. Realize the 4 cannot multiply with the inside of the root because there's a root there. The 4 and the 25 don't simplify. And again, the 5 cannot affect the 21 either. So we've simplified that one completely. Cosine 2u, there's a bunch of different ways to find this one. Let's just choose one of them. I like the top one personally. The reason I like it is, one, it's going to get rid of any square roots we have because we're squaring both of the cosine and sine values. The other thing I like is it automatically gives us a common denominator because the denominator, which is 5 for both of these, would get squared and it has to be the same. Let's look at that process all the way through. Cosine, we're squaring it. Sine, we're squaring it. Okay, root 21 squared is just 21. Over 5 squared is 21. Realize a negative squared is positive, so that goes away. And now we're just subtracting top and bottom squared, which would be 4 over 25. Find your answer, and now you got 17/25. There's a bunch of different ways to do that one. Again, you could plug into some of those other forms as well. For example, maybe I wanted to utilize a different form. 2 cosine squared minus 1. Okay, cosine squared. I'm going to take the value we already found for that, which was 21 over 25. Subtract 1 from it, but okay, that's 42/25 now. Minus 1. Okay, but I need a common denominator. Common denominator would be 25 over 25 then, and I do that subtraction, and again, I still get 17/25. You could do that with the third variation of the formula, which is 1 minus 2 sine squared u, which, okay, sine squared we said was 4 over 25. So it looks something like this now, but 1 minus that. Again, make a common denominator. So 25 over 25. 25 minus 8 is also 17, right? So we do see this is an equivalent form. All three formulas work. It just depends which one you want to utilize, and it might depend on what the problem looks like for which one's easiest as well. Okay? From there, we might look at example 2 real quick. Again, diagrams are definitely very, very helpful. We know we're between pi and 2 pi. That's either quadrant 3 or 4. But they tell us the cosine value is negative. Cosine's negative in the third quadrant, but not the fourth. If you did Pythagorean theorem to solve for the other side, you'd end up getting a value of -5. I could show that briefly. -12 squared would just be a positive 144. We know 13 squared is 169. Subtract it over, you get 25. And then b would have to equal 5. It's negative because we're in quadrant 3. From there, you could just use your formulas. Sine 2u, 2 sine times cosine. Find your fractions. Sine the opposite over the adjacent. Cosine the opposite over hypotenuse. The cosine is the adjacent over the hypotenuse. And then you could simplify that entire thing. If you simplify that entire thing correctly, you'd get 120 over 169. Same idea with cosine, just use the different formulas. Again, I like the first formula. Our first formula is cosine squared minus sine squared. Cosine, again, we said was -12 over 13. Just make sure you square it. Sine, we said was -5 over 13. Just make sure you square it. Calculate the value. This would end up being a minus still because the negative cancels out when we square it. And now 144 minus 25. Do a quick subtraction, and you now get this. Okay, so there's just using the formulas. But this process might look a little different when we start to solve. Let's go ahead. Let's look at some examples of this now. So looking at solving some of these problems now. It says B, solve on 2 pi for cosine 2p minus cosine p. Well, cosine 2p, that doesn't serve me any good because I can't really do anything with that when the 2 is on the inside. So let's change it to a form that we know. For example, you could change it to any of the 3 forms, but one thing I know in this case is we have cosine in this problem. So I'm going to try and leave it as just cosine values on this problem. So for example, I'm going to change cosine in this case to 2 cosine squared p minus 1. Okay, that's just replacing this part with an identity we looked at earlier. Okay, but by doing that now, these are still just cosines, which are good. But if I add this 1 over with that one, those 1's end up canceling. So 2 cosine squared p minus cosine p is all we are left with. Well, if we're trying to solve this, it is now equal to 0, which is exactly what we want, because I see cosine in both of these, one that's squared, so I know I should probably factor this. Remember, you might use u sub to show the factoring, as it might be a little bit easier, or at least appear easier. So, okay, we've factored it. We've set both parts equal to 0, and now we just need to identify the angle that works for p. Well, what angle causes cosine to equal 0? We know that might occur at 2 spots from 0 to 2 pi. That could occur at pi halves or 3 pi halves. Notice I only need the answers from 0 to 2 pi. I don't need to add 2 pi k with any of that. And okay, we look at what value or what angle makes cosine equal to 1/2, and that would occur at 2 spots in the first quadrant and in the fourth quadrant at pi thirds. So pi thirds and 5 pi thirds are our answers. We get 4 answers to this problem. There are all 4 of them. Let's look at another 2 problems. Again, only solving on 0 to 2 pi. Okay, look at A. I see cosine, I see sine. I don't like when I'm solving and I have different trig functions. I like one trig function. So maybe when I'm solving, I can change the sign. Okay, so I know sine squared. Well, sine squared is the same thing as 1 minus cosine squared x. Remember, that is one of our identities we looked at in the last video. It's found from the Pythagorean identities. So, okay, that's one idea of what we might do. Again, different ideas for these different problems. You might find different ways to get to the correct answer. Okay, so we have that. We might distribute that 2 to the inside. But again, I see cosine squared and I see cosine. So in order to solve, I probably need to factor. So let's put everything on one side then. So I add the 2 cosine squared over, I subtract the 2 over, and now I get this. But again, if I want to factor, maybe I look at it with u's because it might seem or appear easier. Notice I have 3 terms in this case, so I'm going to use our ABC method. Find what multiplies to A and C. Find what adds to B. I believe that's just a value of 2 and 1. That allows us to split the middle. That allows us to factor this by grouping, taking the GCF out of both of these. And once we do that, we now have our factored form. So, okay, we have our factored form. We said u in this case was cosine. So if I set this equal to 0 then, or set both factors equal to 0, that could look like this. Cosine x plus 1 equals 0. 2 cosine x plus 1 equals 0. Solve both of these. Find the angle that allows cosine to be equal to -1. What angle makes cosine -1? Well, that would just be at pi. So x equals pi. Solve this other one as well. Okay, what angle causes cosine to be negative 1/2? That would be the second and the third quadrant at pi thirds. So 2 pi thirds and 4 pi thirds would be all three of my answers. You start to see that we still need to use our trig identities to maybe change some stuff around. You might have to solve, and when we're solving, you might need to use factoring, just depending on what the problem looks like. Let's look at one more example. We have sine, we have cosine. Again, I probably want the same trig function just in case I need to factor. Sine we know is 1 minus cosine, we said. I'm going to distribute the 6 to the inside because I imagine we might need to do that if we're factoring. I'm going to move everything to the right side. That way my cosine squared, my leading term, is positive. Subtract the 1 over, that just gives us 5. Looks like similar factoring. What multiplies to 5? What adds to 6? Find the values that work. Maybe factor with u again. It might make it easier for some of us, and that is okay. It is a good strategy to utilize. Find your final factored form. Once you've done all of that, start to take these pieces, set them both equal to 0. But when we do that, remember what u represented. We let u represent cosine. So I'm plugging cosine back into this function and solving. I need to find when cosine x is negative 5. I need to find when cosine x is negative 1. We already knew what angle caused it to be negative 1. That was simply at pi. But realize cosine and sine are bound between negative 1 and 1. Negative 5 is outside of this range. So therefore, what that means is there is not an answer that works. So this part here is not solvable because it is not in that range. So no answer. The only answer we get is cosine x equals pi. Thanks for watching another AP Pre-Calc video. Again, this is our second part of 3.13.